Hello. We need to plan for our Slinky Lab tomorrow. We need to decide tonight a little bit about how we're going to start the experiment, the reasons why we're doing the test, and maybe even plan out our actual experiment, write our procedure. So what I need for you to do is get out your science binder and something to write with and take some notes. In a rough draft form, this will be your rough draft of your lab report that you'll use to write your final copy from. Are you ready? The first thing we have to decide is what question are we going to answer? And we have some choices because of the equipment we have that we could try. We've learned about waves and properties they have like wavelength and frequency and speed. And we need to use a Slinky. Those are the tools I have in the classroom for us to make waves with. If you remember, Slinky, I showed you we could make waves that move back and forth in the same direction, compressional waves, or we could make waves that move up and down like a transverse wave. So those are different kinds of waves we could work with, and we could try and measure their speed. We have stopwatches, we have meter sticks to measure with. So those are some choices we have. But specifically, what question are we going to try and find the answer to? I've got a few ideas I've written down. Take a look at them and see where I'm going with this and think about what question you're interested in. We could just try and find which Slinky wave travels the fastest. That's a very generic question, but we could work with it. We could compare the two kinds of waves I showed you, the compression or the transverse, and see which of those travels the fastest. We could also make small waves and large waves, ones that have different wavelength. Which question do you like the best? Think about that. What I've written down for our purpose, because our question is our purpose, is which wave travels faster, transverse or compression? And we're going to try different wavelengths using the Slinkies to find that answer. So I kind of combined a couple of those questions together and made a purpose. If you like that, copy it down. The next thing we have to do is do a little research. Now, there's a couple of ways we could do that. Remember, you've learned you can get your background information by researching on the internet. You can go back to the textbook and look through that and get some ideas of what you know. You could also look at our notes and your study guide and see what have we learned about wave speed. And you can also take your Slinky and play with it and see what kind of wave you make travels fastest in your impression as you make them. Either way, what you need to write down is what you already know. That's what goes in background information. This is what I wrote down. I know that to calculate speed, you take wavelength and multiply it by frequency. So I think if the wavelength is longer, then the speed's going to be faster. So a higher frequency, a wave that's coming really fast, wave after wave after wave, would also make the wave speed faster because those are the two numbers that get multiplied to calculate the speed. So that's what I learned and know about wave speed. So we need to write a formal hypothesis, and this is one possible hypothesis that I've come up with, and you can copy it for this first go-around, this first experiment, if this makes sense to you and you agree with it. You could change a few words and say it differently. You could say, I think that wave speed and wavelength are related, but I'm going to say that with a decreased wavelength, I'll have increased speed. Your choice. But this one shows that wavelength and wave speed are the variables that I'm looking at. If you put frequency in, then you can test frequency instead of wavelength. But wave speed is the variable we're looking at. It's the dependent variable. What we change, wavelength or possibly frequency, will be the independent variable. Okay, we're ready to design our experiment. And I've put some basic steps here that would be the ones we'd have to follow using a Slinky. We'd have to get our equipment, that's always first. We'd need a Slinky, stopwatch, and some kind of measuring equipment. We're going to use the tabletops and make the different waves. We're testing transverse wave against compressional. So we need to make the different waves, maybe start with a transverse wave, maybe start with a compressional wave. To make the transverse wave, you're going to shake the Slinky from side to side. Then we're going to see how long it takes to make 10 waves. If we have 10 transverse waves traveling down the table, how long does that take? And then measure how long the wave is from one crest to another. And we have to do this test 3 times. What if one time you mess up and have to restart? You need to throw it out and do a 4th one, yes. But by doing 3, we get a good average. So those are the first 3 steps I came up with. Notice the details. I didn't just see, get a Slinky, make a wave, measure it. I said a lot more than that in steps 1, 2, and 3. Make sure you take good notes too with details in. After we've made that first kind of wave, we want to make a second kind of wave. So if I was wanting to do shorter and then longer waves, I'd say that. Make a shorter transverse wave and then repeat everything from step 3, doing it 3 times and recording that data. And then finally trying with a compression wave and again repeating step 3. Put the details in. Make sure you're not forgetting anything important that you'll need to remember. Your procedure should be detailed enough that someone could walk into class and do the experiment exactly right, following the steps you've written. You know what? If you've got your purpose, your background information, your formal hypothesis, and a rough draft of your procedure written down, as long as you have all those things with you when you come to class tomorrow with your science binder, we're ready to start doing the experiment the moment we've taken attendance. If everybody's ready, we can get started quickly. I'll see you in class.